Hello, Math 2 students. Do you think you can make a triangle out of any three line segments? Well, sometimes you can, but sometimes you can't. How do you tell the difference? Maybe you have three segments. You're trying to put them together. Their endpoints are touching, but are they going to make a triangle or not? What you need is the triangle inequality theorem. Keep watching, get out your notes, write this down, and you will be able to tell whether or not three line segments can form a triangle. Can a triangle be constructed from any three line segments? Well, the answer to that question is no. There are line segments that when you put them together, endpoint to endpoint, do form a triangle. But there are other line segments that when you try to put them together to form a triangle, they do not fit. So there are three scenarios that can happen: the gap, the drawbridge, and what we're looking for, the triangle. How do we know that those segments can form a triangle when being joined by their endpoints? First of all, what is the problem with the gap? Well, we have the longest line segment, which is x. And then in this case, k plus z is less than x. And so they can't stretch across the longest side and touch to form a triangle. Instead of touching, there's a gap between side k and z. The next scenario is when you actually can form a triangle. As you can see, our longest side is x, and k plus z can't fit on top of x because they're too long. So the sum of side k plus z is greater than side x, and that forms a triangle. Finally, if you look at the third one, the drawbridge, side k and side z, when we take their sum, when we add them together, it comes out to exactly the same length as x. And so when k plus z is equal to x, it looks like a drawbridge. The two sides fit perfectly over the longest side, which does not form a triangle. So in order for three line segments to form a triangle, the two shorter segments need to add up to more than the longest segment. So now in example number 1, is it possible to construct a triangle with side lengths 7 and 2 and 9? Well, our longest line segment is 9. And then we have a side that's 7. And we have a side that's 2. And as you can see, if we add up the two shorter line segments, 7 plus 2, it will equal the longer line segment, which is 9. And in order to form a triangle, we need 7 plus 2 to be greater than 9. But it's not, it's equal to 9. So the answer to this problem, is it possible to construct a triangle with side lengths 7, 2, and 9? The answer would be no, because the two shorter sides do not add up to more than the length of the longest side.
Example 2. If possible, construct a triangle with the given side lengths. Well, it looks like this is going to be possible because in my mind, if I imagine side 1 and 2 and I put them together, that will be longer than side 3. If I imagine side 1 and 3 together, those two together will definitely be longer than side 2. And if I imagine putting side 2 and 3 together, those two will be longer than side 1. So it looks like every two sides that I could pick of the triangle will be longer than the third side, which means it is possible to construct a triangle. So I'm going to start by constructing side number 1. So I need to put a line segment that is longer than side 1 on my paper. Then I'm going to go up to side 1 with my compass and set the radius so that it matches the length of side 1. Once my radius is set, I'm going to go to one end of my line segment and I'm going to mark that off. And so this line segment right here is side number 1. Now I'm going to go to side number 2 and set the radius of my compass so that it matches the length of side number 2. Once I get that set, I'm going to go to either end of my line segment of side number 1, I'm going to go here, and I need to swing an arc, and this arc is going to be the length of side 2. So somewhere side 2 is going to go from this point to that arc, and it will be the length of the radius of my compass, which matches side number 2. Now I go to side number 3, and I make sure that the radius of my compass matches that side length. And since I put my pivot point here on the last arc, I'm going to go to this end point, and I'm going to swing an arc that has a radius exactly the same as side number 3. So now if I connect this point and the X that I just made, that will be the exact length of side 2. And this arc, remember, is the arc when the radius matched side 3. So if I go from here to here, that will be side 3. So this segment here is exactly the same length as this segment here. This segment here is exactly the same length as that segment right there. And this segment here is exactly the same length as side number 3.
In example 3, they want us to use a compound inequality to describe the possible lengths of the third side of a triangle whose sides are 24 and 38. So in this problem, one of the most difficult things that students struggle with is writing their answer as a compound inequality. A compound inequality is essential in this lesson because it's how you describe the possible lengths of that third side that can actually form a triangle. So in words, in my example, I have the third side is between 8 and 14. That's all we're trying to say, but we're trying to say it mathematically using mathematical symbols. As a graph, it looks like this. And you see that there's an open dot above the 8, which means 8 is not one of the possible side lengths. We have an open dot above 14, which means 14 is not one of the possible side lengths. But in between 8 and 14, the whole number line is shaded in, which means any number greater than 8 and any number less than 14 will be a possible side length. And so the possible side lengths are between 8 and 14. Now, how do you write that as a compound inequality? Well, we need to say that x, or our unknown side length, is greater than 8. And that's what this part of the compound inequality says. We also need to say that the side length needs to be less than 14. And that's what this part of the compound inequality is trying to say. So when we put those together, we have x is greater than 8, but x is less than 14. Notice that the numbers are in the same order that they're in on the number line. 8 is to the left because 8 is the smaller number. 14 is to the right because 14 is to the right on the number line. It's the bigger number. And then we want to always say that our side length, or our x, is bigger than or greater than the smaller number, but our x, or our side length, is less than the bigger number. We're putting our x between 8 and 14 because the possible side lengths are between 8 and 14. So now once we understand that, we can write our answer to example number 3 as a compound inequality. So when I do problems like example number 3, I like to think of it this way. There's 3 possible scenarios, but one of them is actually impossible. The side length that's 24 centimeters could be the longest side of our triangle. The side length that's 38 centimeters could be the longest side of our triangle. Or the unknown side could be the longest side of our triangle. Well, the one that's impossible is 24 can't be the longest side because I already know that it's not longer than 38. So there's really only 2 scenarios I need to think about. I need to think about what if the longest side of the triangle is 38, and what if the longest side of the triangle is the unknown side. So if I can look at those two scenarios, I should be able to figure out the range of numbers that can make that third side. Okay, so if our longest side is 38, we're going to have one side that's 24, and we're going to have one side that's unknown. And what we're looking for is that unknown side. If the unknown side is the longest side, then we're going to have one side that's 24, and we're going to have one side that's 38. All right, so the scenario on the left, 24 plus that unknown side needs to be greater than 38. So right now, if I think about it, 24 plus 14 would equal exactly 38. So if the green side is 14, then we'll get a perfect drawbridge. If our green side, the unknown side, is 13, then we're going to have a gap of 1 in between. The 24 and the 13 won't stretch all the way across the 48. There will be a gap. So what we need is we need a triangle. We don't want a drawbridge. We don't want a gap. So we need our side, the unknown side, to be greater than 14. So this is the first part of our answer. All right, so anything greater than 14 will make a triangle. But at some point, that unknown side could get to be too long so that the 24 and the 38 can't stretch all the way across. So when I add up the 24 and the 38, that makes 42, 62. And so if our unknown side is 62, we will get an exact drawbridge because 24 plus 38 adds up to 62. So 62 gives us a drawbridge. And if I make it 63, now we will have a gap because 24 and 38 can't stretch all the way across 63, so we'll have a gap of 1. So it can't be bigger than 62. It needs to be smaller than 62. If that unknown red side is smaller than 62, then the 24 and the 38 will add up to more than that third side. So that's going to look like this. We want our side to be less than 62. This is the other part of our answer. So now the only thing left to do is write our answer down as a compound inequality. We need the third side of our triangle to be between 14 and 62. Since 14 is the smallest number, I put it on the left. And I want to say that our side, it has to be longer than 14, so that's how my inequality sign is going to go. And then I need my side length to be less than 62. And so as long as I have a third side that's between 14 and 62, I will be able to form a triangle along with the side that's 24 and the side that's 38. So for example, 10, that side length would not work. It would be too small. 80, that side length would not work. It would be too big. But anything between 14 and 62, like 15, 20, 38, 49, 61, all of those numbers could possibly be the third side of this triangle because all of those numbers are between 14 and 62. Thanks for watching. After watching this video, this is what you should know. You should be able to look at 3 line segments and be able to explain why they form a triangle or why they will not form a triangle. Another thing that you should be able to do is you should be able to look at 2 line segments and explain the range of numbers by using a compound inequality that could be the third side of a triangle if you put those line segments together.